We're here at one of RCO Engineering's woven carbon fiber manufacturing station with Dave Robertjohn.
This is a 3K 2x2 twill, which does move in different directions to show you how it can go around different geometries. It's a 2x2 tool pattern, meaning it has 2 under, 2 over. And the 3K comes in many different versions, 3K, 6K, 12K, and that is a tow line which represents the 3,000 strands per bundle, which in this situation, the 3K is probably one of your more strongest carbon fibers, but this is in a dry form.
Okay, so this is a dry form, and then you have some other woven carbon fiber here. What's the difference between the two?
And this is the same thing. It's a 3K, but it also has the resin pre-impregnated into it, and that's where it gets its name, prepreg. It has and also a 2x2 twill pattern, and under heat and pressure will give you your shape and your form to make the parts.
So here we are at step 1, the cutting station. So Dave, what's important to know with respect to cutting a piece properly to get it ready for the press?
At this station we cut our blanks per prescribed tools, either squares or rectangles, and we just cut them off here on the table, and then depending on how many plies you need in order to do that, to achieve that.
And you just use a utility knife?
Just done with a utility knife.
To cut it. Now remember at one point you told me that sometimes it's important to go according to the weave or cross the weave, and I'm not sure you do that here, or?
Most of them are, there's no direction requirements. It's either 0 or 90 degrees, but like you had said, we can also cut this on the bias or on a 45 on an angle, and that'll allow you to get into tighter shapes if need be. It'll allow the material to stretch out and form.
So now we're going to shape the part that we just cut. So Dave, what can you tell us about the equipment and the process to shape our carbon fiber piece?
This is our 100-ton press, and this is an aluminum tool. We have our cavity and core in here bolted up in the press. It is also heated by cal rods, which run through here, and we control the temperature. It runs for about an 18-minute cycle minimum.
Okay. So then it doesn't matter how much longer you can run it for a little bit longer. And
we try not to go over about 25 to 30. Okay. 18 is minimum, yes.
So now we're here at the cooling station. Dave, why have a cooling station?
When the part comes out, it's still somewhat malleable. It will move. So what we do is we lay it on just a simple butt, and then we weight it down just to hold it in that position.
For how long does that?
It'll usually stay here for the 18 minutes, which is the cycle time of the next part coming out.
Okay. So then from the cooling station, I understand we trim off the rest of the what we're not going to use in terms of the perimeter.
Right, then it goes over to the laser, and then they will laser around the periphery of the part and trim.
Okay, and so then what do you do with the scrap?
The scrap can be thrown away. It's EPA safe at this time because it's cured out. We are looking into having recycling done, where they'll grind it back up and reuse it.
So we started out with a rough piece that's been shaped, but we needed to trim it, and now we have a trimmed piece. So now, Dave, what happens with this?
This part will go into inventory after inspection, and then our materials handling people will pull it and take it up to the assembly line station so that it can be assembled into a finished seat.
That's great. So for more information on RCO's carbon fiber process or any other engineering or manufacturing service that we offer, you can email us at rcosales@rcoeng.com.